Here we go. I think we are ready, gentlemen. It is time once again. Well, the SBAU Astro Hour, and Baron's got his new voice. It's a 1 hour fun-filled vlog we do live every Monday morning, 11 to noon, for the Santa Barbara Astronomical Unit. It's the South Central Coast's longtime telescope and astrophysics club. We delve for a whole 60 minutes into the mysterious, mesmerizing world of cosmology. I'm your host, Ron Heron. As vice president, I learn a lot from my very knowledgeable friends and comrades on the screen here from SBAU, and I'm going to introduce you to the gang. I call them the Brain Trust in a moment. You can watch us on YouTube, hopefully, just 20 seconds late. Come to our first Friday meetings where we have great speakers up at Santa Barbara's Museum of Natural History. And check us out at sbau.org, people. Lots of outreach events, too, including our second Saturday star parties, but I think it's going to be switched again no, it isn't. In June, it'll be switched. We'll have our second Friday for the meeting with Dr. Martinez talking about space junk. And that's our next speaker. And I guess it's the cloudy time, gentlemen. Let me introduce everybody. First of all, here's what we're going to talk about: lunar rays. Wasn't that an Academy Award-winning show starring Sally Field? Oh, no, that was Norma Ray. Lunar rays, crater ejecta. Ooh, both sides of the full moon. We got an amateur spotted an exoplanet. Talk about that. Lyriad meteor shower has arrived. Planet Mars has a rival in the sky. Some people mistake them for each other. Antares, it
Yeah.
is one mother of a star, man, in Scorpius. A recurrent nova is about to pop again. It's in Corona Borealis. And in the UK, they picked up pieces of a recent meteorite that fell to Earth. We're going to learn about that. NASA wants to send a car-sized drone to Saturn's exciting moon Titan. Here's a New York Times story from last Thursday, the 18th. Earthlings have only a few more days to glimpse Pons Brooks, the comet. It's going to go away for another 71 years, and it looks like the Millennium Falcon. So we may not be able to see it in a night. It's been a few days since this came out. And Boeing has a spacecraft. They're going to launch it on May 6th, I guess. It's called the what? Starliner spacecraft. Let's meet the gentleman and get some comment and have some silly cartoons. Ladies and gentlemen, our beloved president, Jerry Wilson, on the left of the
Hello.
on the upper. And his wife is there with him because she just wished me a happy something or other, Pat Forgy. And Chuck McPartman is our incredible outreach coordinator in front of the Ukrainian flag, in charge of almost all the events. Nobody's better than Chuck, I got to tell you. And Pat McPartland, his wife, holds down two jobs in the club, merchandise manager, and she's now our new treasurer. I guess we've lost Colin Taylor, haven't we? He's been stuck in a home somewhere. I don't see him anymore.
I saw him the other night.
What?
I saw him the other night.
Does he come to meetings? Is he still in the club himself? I guess.
I think
Yeah.
he was at the star party.
Well, let
He
me
was
introduce that
he was
talker.
at the eclipse too.
Tim
Oh,
Crawford.
Eclipse. That's what it was. Eclipse.
His name is Tim Crawford, resident lens and telescope expert, very shy guy.
Happy birthday, Ron.
Yeah, we're not going to go there. Is married to Karen. Tom Whittemore edits our monthly newsletter, and he just retired several years ago from Westmat College and never been happier, apparently. He's married to Maureen. And Bruce Murdoch is married to Bonnie, longtime supporter and telescope enthusiast. And he had something to comment about one of the forwarded silly science cartoons we're going to throw on the screen for you. It's not that funny, but that one, if you do bring it up, Jerry, you're going to need to explain it. Here we go. This is a typical crash into a building by a giant insect. It would be a windshield company. Acme Windshield. It's right out of the Wiley cartoons of the Roadrunner and well, anyway,
The Acme Company is, yeah.
that's been up there for a while, but I'm glad I remember it. And it's crazy stuff here. Here we go. He gets to send these out to us. Two criminals have escaped from jail, from prison, and they've gone a little too far. Hey, Bob, ho, I think we dug a little too far, and there they are. Their own crater on the moon. Here is a look at possible class distinctions in future space flights, as one astronaut says to the other, next time we travel to Mars, We're going first class. Screw this economy.
Yeah, you can see the first class seats up here, and they're in the cargo hold.
Well, seems to be cut off. Okay, first got it. And then down below is here.
Yeah, they're down in steerage.
Yeah. Couple of boys trying to play their video games are being put in their place by AI. Dude, I've never made it to this level before. I have no idea what to do. And it says, go outside and play. AI is a good thing. And Isaac Newton came up with that incredible Pink Floyd album. What was it called? Far Side of the Moon?
Yeah.
Designed the cover. We all have our copy, and it's definitely the prism separating the spectral lines. These two pieces of the puzzle are the two boxes should be reversed. Let's go to the right one first. The three researchers, obviously ladies, stick figures, are meeting and sharing, I guess, a lab. Due to funding cuts, ladies, the three of us will be sharing the lab. I'm studying avian growth, birds growing up. And the other one says, well, I'm working on laser technology. And the third one says, feline intelligence, cats. Now go back to the first one, and that's what happened. Well, it turned out worse than expected. Silence human, says the kitty cat on side of the huge bird about to shoot him with lasers. Get a pretty good example of what could happen. Okay, that puts us in the mood. A lot going on, including Earth Day, which had its start right here, I believe, in '69, did it not?
Yeah, oil spill, right?
Yeah, I think it was. And I love having my birthday, which happens to be the same as Santa Barbara's birthday, right next to it. But we got no plans. And there's also a astronomy day coming, but I don't know. We'll give a recap with Chuck later in the hour, I suppose. Let's look at the moon. Jerry, Mr. President.
This is a photograph taken by one of our members, Bruce Murdoch. It's not quite full, but it's full enough that we can see prominent ray craters in here. Now, when the moon is full, which happens tonight, is it tonight or tomorrow night? Tonight, I think. Let's see.
That's nice, Bruce.
Yeah.
Thank you. I enhanced the contrast on this, which brings out the rays.
Yeah, it's a nice job. But you see a lot of these things, there's not much to look at on the full moon because we rely on shadows to show the thing, to pick out features. This one is
Copernicus.
Full moon, we can see these prominent ray patterns that are not easily visible at other phases. You can see probably the biggest one here. What is this, Tycho down here?
Tycho. Yeah, Tycho.
And Copernicus over here. And then there's other ones around. This one down here has always made it look like a peeled orange to me.
Well, at Star Parties, I explained that's, the meteor that hit that place came in very high speed.
Yeah, and it was big.
Yeah. Whereas the one at Copernicus was pretty low speed, because you can see all the rays are all wiggly woggly because the stuff rolled away.
Also, this hit a sea which is a frozen lava sea, and the material is harder to scatter. It's a harder surface. Up here in the highlands, it's more powdery because it's been hit. It's older. It's been hit a lot. This is relatively new surface, and it hasn't been completely ground up yet. But there are a lot of ray craters on the moon. This is a list, actually a partial list of what the craters that have prominent visible rays: Aristarchus, Copernicus, Kepler, Proclus, Dionysius, Glusco, and Tycho. Then smaller ones are Censorinus, Stella, and Linnae. Then there's on the other side of the moon, which you can't see from Earth, Giordano Bruno, Necho, Ohm, very resistive there. Jackson, King, and the smallest, most prominent, Pierazzo. Now, a lot of these were viewed by, this is that list. This is Proclus, and it's taken from Apollo 15. And you can see that it's not looking straight down on it. It's kind of foreshortened. So this is an ellipse. So to me, this suggests that the object hit this way even though foreshortening would give it an oblong look like this, but because the rays come blasting out this way, I think that scattered it out.
Jerry, I'm not seeing your picture of the crater as you describe it.
I am.
You are?
Yeah, I'm seeing it. No caption, but I'm seeing crater.
Is that Proclus, Jerry?
Yeah.
Because that's Mare Crisium. That's right on the edge of the sea. Mare Crisium.
Chuck, you're not getting the picture?
No.
Oh,
Oh, it's a separate. Oh, it's showing up as a separate screen for me. There we go. I got it.
Okay.
How that happened.
Quick question. Can I throw in a question?
Yes.
These are the same rocks that fall here and become meteorites. Are there pieces of iron and nickel that are different from regular moon stuff that
Ron, nickel irons don't come from the moon. Nickel irons come from differentiated bodies out there from the asteroid belt. Most of the ones from the moon are rocky, but they're so similar to the lithosphere of the Earth that it's hard to tell that they came from the moon.
I'm not saying they came from the moon. I'm saying the same stuff that makes these craters and these rays are the ones that hit here. And
yes, absolutely.
And so is it possible we might find some damn good meteorites? That's what the rock is called. Meteors is when they're in the air. When it becomes a rock, the one you have, at your events, we're going to find them in these rays, you suppose? Pieces of them.
Oh, that's what the lunar dust is full of, little micrometeorites, little nickel iron spherules.
Is that right?
That's why it's so bad.
The moon doesn't have the geological activity that on the Earth erases these kinds of craters. The moon is pretty much, once it gets hit, it has to be hit again to alter the first hit. Up here, we have oceans and waves and tides and weather.
Gophers.
Yeah, and life that,
Do you know the
life that grows over and erodes these things?
Do you know that big, huge mile across crater in Arizona is owned by a private family that charges $29 to get in and makes a fortune?
You mean the Barringer meteor crater?
Yeah.
Yeah, it's right after.
The guy Barringer,
right?
Bought that crater because he believed that there was a large deposit of iron ore buried at the bottom.
Back when he needed that.
Turned out the thing had fragmented, and so it was more like a shotgun of iron that blasted the whole crater. So there was no single deposit to mine. So it's about time his family made some money on it.
There's a plume of microscopic nickel iron spherules that goes from that crater all the way to Kansas.
Wow.
Oh.
Well, that's our ray.
Yeah.
Wow. Well, I thought maybe it'd be neat if you wanted to see it for free, just go to the far side and hike in, but they've got fences all around it and alarm systems. They want their money.
Yeah. Well, they also don't want people collecting the meteorites because they were over collected. Yeah.
And people hiking around in there would, they would collapse things and cause landslides and deface it.
It might fall too.
Yeah, that could be too. Yeah, but they're very fortunate in how close that asteroid came to the visitor center.
Yeah.
Good line. All right, rays. Do they mean anything to us in future exploration, the rays?
Not really.
Okay.
This is Pierazzo. This is taken from the Clementine spacecraft. Clementine was an Air Force satellite launched to do for the U.S. Geological Survey and Air Force to get a really accurate map of the moon with heights and close-up pictures and features for future lunar explorations. It was the first spacecraft that suggested that there was water on the moon because they got emissions from hydrogen deposits in water.
You think those two circles that are off to the left are reflections in the lenses?
I think they're craters.
Oh, they are, huh? They don't look like craters. That's the thing.
No, but blemishes from.
But the water is at the poles, right?
Well, the ice would be at the poles, but there's water trapped in the minerals all over.
Oh, is that right?
Yeah.
Oh.
But Clementine saw the frozen ice at the poles, not the water all over. That's more recent.
Okay, but these recent far side of the moon craters and rays you're showing us are only about 30 years old. We didn't see the other side of the moon before Apollo, did we?
Yeah, seeing it's about 30 years old, but the craters are much older than that.
Well, 1959 was the Luna mission from the Soviets that got pictures of the far side.
Yeah.
And that's when we learned there weren't really any Maris over there, any seas.
Not really big ones, but here you can see. It's kind of like this stuff.
Other
This
side
is
is really
Giordano Bruno. And this is an Apollo 11 image. Now, this is on the far side of the moon.
I can hear Zarathustra right in my head as this thing is.
Yep.
And
Ron,
another
Ron.
example, this is
Did you
South
say
Ray taken
Yeah.
by Apollo 16.
What more?
Yeah.
What did you
Oh, I
say?
was just going to say, Ron, Giordano Bruno was burned to the stake in 1600 for professing there might be other civilizations out there in space.
Yeah.
Yeah.
Lord.
Too
The
progressive
Campo
for
de
his time.
Fiori. He was burned alive at the Campo de Fiori. You
Jeez.
know, would you say the field of flowers, literally in Italian.
Well, makes me feel better about today. I keep thinking it's never been this
Happy
worse.
birthday, Ron.
Okay, got it.
So this is a fairly new crater, a young crater, still got a lot of structure in it. But a nice ray system.
Where is it?
This is an Apollo 16 image, and I think, let's see, in the list,
Far side or this side?
yeah, I think it's the far side. Oh, there it is. Yeah, it's on the far side of the moon.
Okay,
Giordano Bruno.
Pink Floyd.
that black thing in the middle is the crater, the hit point. It's not a device. It's not a orbiting
No,
machine we're looking at.
it's on the surface. It's a feature of the crater.
Wow, that's what they look like. Nothing but rays.
Okay.
Looks like an insect.
Yeah, it does. To the night sky we go.
So this is tomorrow morning at 4 a.m.
I was going to say it's the morning sky.
Morning sky. All right, the same thing.
Yeah.
Looks the same to me.
And you need to get out more.
That's true. Ophiuchus is on there. I love that one. That's fun to say.
That's the 13th sign of the zodiac.
Yeah, the serpent bearer.
Wow.
So this is the radiant of the Lyrid meteor shower. This is going to be a tough shower to watch because the moon is full, and that's going to dim a lot of or make the dimmer asteroids, or not asteroids, but meteors invisible. You want to look farther away from the radiant for the streaks that are long like this, because they're not traveling directly toward us. A meteor coming right toward us from the radiant would just be a dot that became bright and then disappeared. You wouldn't see a trail. Hard to spot those.
Hopefully not really big.
Yeah.
And getting bigger.
Yeah.
That is actually how objects determine if they're on a collision course with something else. Yeah, there is no radial motion there, or no, there's no angular motion, there's only radial motion.
Yeah.
So an object just gets bigger and brighter, but it doesn't move off of its position.
Right.
Yeah.
That's the core of most missile guidance systems.
Yeah, not much transverse motion, huh, Jerry?
Right.
Yeah.
And your eye is sensitive to that. If you even unconsciously, if you pick up, say, someone threw a baseball right at your head, in your peripheral vision, your eye will pick up that motion, that no angular motion, but getting bigger, and you'll reflexively guard against it.
Huh.
Well, do you suppose there's an uptick of meteorites that are found that actually land on Earth during the showers, or is there any way to measure that?
I don't know. The bright ones are there. We get several tons of space rocks and stuff every day, I think, and space dust.
Right.
It's estimated at 50 tons a day. Yeah.
Yeah.
But it's all sand size. It's not the size.
Not all. There's 2 Hiroshima-sized blasts in the atmosphere just about every year.
Wow.
And you'll see a little later on, you'll see one that landed in England, 3 years ago. We'll talk about that.
Right.
Winchcombe.
Can't wait.
So this is, it's there. Give it a try, but don't expect great results. the bright, as the next section says, the bright moon simplifies the sky. So that's trying to get positive.
Kind way of saying it.
Yeah, positive out of a negative situation. So what we're looking at here is something I didn't know. This is the North Pole. This is the Little Dipper or Ursa Minor. Unfortunately, it doesn't have star names here, but we can talk about those.
Well, Kokab is one of them.
The Big Dipper is down here, and it has nice, all the star names on it. And then it has, and I'm used to the asterism just being this, but this thing goes out here. That must be the nose.
Yeah, that's the nose of the bear.
And this must be a front paw.
Yeah. And then there's two hind legs, but one of them is kind of off screen.
Yeah. So, but anyway, all the name stuff, the bright stuff, these two are easy to pick out, but they're circumpolar. But they're basically for here in Santa Barbara. They're up all night in some position or another. Right now, this is just skimming along the top of the mountains.
Actually, not now.
Right? Oh, it's the other way around.
Yeah.
I've got this upside down for this season.
Are those circles and lines we're looking at in the sky, gentlemen, the same longitude lines that are on Earth?
The same latitude lines, essentially.
Latitude.
They're very faint, though. You only see these on extremely dark nights.
Now these will travel counterclockwise on this chart.
That depends on whether you're looking and you have the chart set up to look from inside the sphere to the outside or outside the sphere to the inside.
Oh,
This is set up, I believe, to look down on the sky from outside.
oh,
But in real life, if you're seeing this pattern, it would be going counterclockwise. You're right.
Yeah.
okay.
I mean, Tim.
Yeah.
Ugh.
So the thing that I didn't know until Astronomy Magazine pointed it out in this blurb, is that these are juxtaposed, so one always pours into the other. So when this one is down and this one's up, then the bowl here is pouring into this, and here this bowl is pouring into this one.
I'll be darned.
Yeah, that's what I thought.
Yep.
I thought Tim will be darned.
Yeah.
Of course, when they're sideways to sideways, then they're both pouring out on something else.
Yeah,
Yeah, on us.
but you kind of whistle and wait,
So
And if you poke a hole in the bottom of the Big Dipper, you wet the big lion.
Oh, really?
I'm sorry, gentlemen. I see the Little Dipper, but I don't see the Big Dipper. Where is?
The Big
Right
Dipper
above
right
the
here.
blue.
There's the bowl, and there's the handle. Now, Mysore and Alcor, two names for the one star there, is actually a double star. I don't know that it's a binary,
Well,
but
yeah.
There are
What's that?
two double stars there.
There
There's
are
about
actually
6
six
stars
stars. There are
right.
6 stars there.
Yeah, but they're not. They're in two separate binary or groups.
Yes.
yeah. So you're getting a little ahead here, and but the thing is that on these nights, this is an eye test because you can, if you have good eyes, you can actually see that Mysore and Alcor are actually 2 stars at that point with your naked eye, if you have good eyes.
Yeah, never seen it.
And those names come from Arabic phrases for the puzzle or the test and the answer. Because if you could
Huh.
see them, you could be an archer in the army. If not, you were a marcher.
Okay. I understand that the name of one of our branches of mathematics, algebra, comes from Arabic also.
Oh, yeah.
And al means the, and gebra means the unknown. So you are in algebra, you are always looking for the value of the unknown.
Algebra 1, just solve for X. I had no problem. Got an A.
So, what if
Is it-
it wasn't in the
Is it
formula?
related to algebra?
Wow.
Well, al is the, you know,
Yeah.
Alcor, all these als.
Right.
Okay.
So that's an article, Tim, like the.
Okay.
In Hebrew, it's El. Elal, airplanes.
Okay. Yeah. Yeah, Mysore and Alcor, they're cool.
Yeah. I always thought it was the horse and the rider too.
That's the
Yeah.
American Indian version. Yeah.
Okay.
What is the puzzle and the answer? That's Arabic?
Yeah.
Okay.
And then in some parts of India, when you're single, you see one, but when you get married, you can see two.
Well, word
Okay,
calculus.
we won't go there.
Maybe a program, I can call you back.
What is camelopardalis? Is that
That's the giraffe.
This giraffe.
Oh, okay.
Yeah.
That makes sense. Probably
This-
got that word from.
The spotted camel.
Spotted camel. I thought it meant the long-necked camel, but anyway, okay.
Love it.
Now we move to the south and the morning sky. This is
Scorpius.
yeah, this is the constellation of the Scorpion, Scorpius. It is near Sagittarius, so it's in the denser regions of the core of our galaxy. And it has a lot of really nice star clouds and a lot of really nice globular clusters and nebula in it. But because of the full moon, we're looking at this bright star, Antares, which means rival of Mars. Aries is the word for Mars, and anti means against or rival. So it's right here. It's a gigantic star. It's got a nice, easy globular cluster right next to it. And it's also got some nebulosity around it called Rho Ophiuchi. So this is a easy pattern to spot. It's almost all visible. There's a few third magnitude stars in here, but even in a full moon, you can see this. And it's
there's two stars to either side of Antares, and I think both of them they either translate out to artery or vein, and so it's kind of interesting because they're both signifying some kind of vessel, and Antares being the heart of the Scorpion.
Right.
Well, if they translate to artery or vein, one's got to be red. That would be the artery, and veins are blue.
now
Yes.
if it's not cloudy in your location and you look through at the Antares in say a 6-inch or a 10-inch telescope, and if the seeing is good, because sometimes if the seeing's bad, the star looks like it's a sparkler. It's throwing off colored flares and stuff.
Yeah.
That may be pretty, but to astronomers, it's an indication of bad seeing.
Bad seeing. Yep.
That is, you can't see a lot of details. But if it's really nice, a lot of people can't see colors in stars, or they have trouble discerning color. But if you look at the Antares in a larger scope, like an 8 or a 10-inch, it's definitely a red star. And that can help them discern that it's red.
But is the real reason, gentlemen, that we have bad seeing on full moon nights the atmosphere? If we didn't have an atmosphere,
no, it has nothing to do with the full moon. The full moon is just glaring out everything and hiding the fainter stuff. But you can have good seeing or bad seeing during any phase of the moon.
What if you were an astronaut in a suit on the moon, which has no atmosphere? You know those pictures that show just black, and because the moon is so bright, you can't see anything. Would you not be able to see anything up there if you had a telescope?
Oh, no, absolutely. You'd be able to see quite well.
Okay,
You
but
probably see so many stars you couldn't really identify who was who.
Yeah.
So the pictures don't show it because of the brightness of the surface,
Right.
the moon. Okay, got it.
But you can take time exposures from the moon if your mount is tracking, and those are just as good as the Hubble telescope if you had a big enough telescope.
Yeah.
Providing the seeing is good.
Yeah.
Well, there's no
Absolutely.
seeing
Perfect.
on the moon.
Oh, on the moon. I thought, all right. Yeah, I didn't get that.
Yeah.
I don't
So
recall.
Antares is a red supergiant star.
Right.
Oh yeah.
Much brighter than the sun. It's 60,000 times brighter than the sun.
Wow.
Yeah.
It has let's see,
But only about 57 times the mass or something like that.
Only about 12 times the mass.
yeah.
12 times. Okay, that's
Pretty
not,
fluffy. It would hold 1 billion suns, but it's only 12 times the mass.
and
Yeah.
yet
This is
It
an
also has a
infrared.
companion. It has a companion too, and I've actually seen it. Real steady skies.
Yeah, this is the size of Antares.
Mhm.
This is the radius is 300 million kilometers.
Wow.
The orbit of Mars is less than that. So this would reach out between the orbit of Mars and Jupiter out here. So it's in the asteroid belt getting rich.
Good
So
Lord.
this is
The captions are kind of weird there. It should say red supergiant for Antares and then red giant for Arcturus.
Yeah.
Instead of just orange star.
But that little dot right there, that's the sun.
Yeah.
that right there is our sun.
Wow.
And yet
Um,
it's only got 12 times our mass and somehow there's plasma going on.
Yeah.
Wow.
it's 880,000 miles in radius. Is that right? Radius or diameter?
Diameter, I believe.
That's diameter.
Yeah. Okay, good.
So it started out like our sun. Our sun's going to do that someday, supposedly.
No, not supergiant. It'll do like Arcturus.
Oh,
Like this one. Yeah, this is just a star that's swollen up because it has so much radiant heat coming out. This is started out as a big star. This is a picture of Antares, and after my discussion of it being red, it's white right here because this
We
is
got
a
the wrong
false color
filter.
picture taken in the infrared.
Okay.
Oh,
so
okay.
it becomes white.
So these are the stars that surround it in the constellation. One down there. I don't see, unless this is the M4, but this might be tighter in than that map.
Yeah.
But this is a complex of nebulosity that in the visible light is very dramatic. It's called Rho Fuchsiae.
Yeah. Looks like a bird's head.
It does a little bit.
Yeah.
You know the name, I'm sure that you guys all know, but for the audience, all these names of nebulas are all just popular or things. There's no official names for these things. The official thing is usually a catalog number like NGC, whatever it is. So, or a Messier number like M4.
Well, M42 also looks like a bird head on one side of it.
One does, yeah. This is a picture, not really a actual snap picture. It's from the VLTI, and it's a reconstructed view of the surface of Antares. That's a radio telescope, or is that a really very large?
Very large telescope interferometer? Or?
Yeah, something like, yeah, that, you know,
So,
yeah.
That's where they have the 5 systems down in South America, and they
Yeah.
treat them like an optical interferometer.
So they construct this by looking at, they can get high resolution in one dimension at a time because of their interferometry, and then they have to go through a process to assemble the picture. So there is structure, hot spots and darker spots, very similar to Betelgeuse, which we discussed earlier with boiling convection cells on it. And that boiling action had led to Betelgeuse being claimed to be a very fast rotating star, but it's not. It's just the internal structure is in constant motion. Antares may be the same way.
Does science know how many sun masses would fit in Betelgeuse?
Yes.
It's not 12. It's more than 12 suns. I mean,
It's very similar to Antares.
Really? Okay. It's not as hot then, I would imagine, as our sun.
They're both cool, yes.
Relatively.
You could probably, through both Betelgeuse and Antares, you could probably fly a spaceship through the outer reaches of this. It's very tenuous.
Yeah.
It's this is expected to, based on models, this is expected to go supernova in 1 to 1.4 million years from now.
God, that could be any time, guys.
Betelgeuse is apparently much closer to it. It's going to happen after midnight.
Yeah.
Well, if there are any extra planets around them, they don't have very big stellar eclipses, I would imagine.
When you have when you have two objects orbiting each other, you can tell a lot about the things. Just if you can get a good distance to it, then you can get the size of the orbit and you can get the mass of the objects. And so Antares actually has a second star around it, a 5.5 magnitude blue-white sequence star, spectrotype B2. Antares B. And it has an unusual spectra because of all the debris that's in around Antares and being picked up and absorbed by Antares B.
Hmm.
So let me stop sharing this and see if I can.
Now, Antares B is rotating around Antares?
Yes, it's an orbit around it.
Oh,
It's the one that sucks off Antares, isn't it? It's what, a white dwarf?
No,
Well, it's not a white dwarf, but
No.
it is smaller.
yes.
Okay. And
I
supposedly
saw,
some
I
leak.
saw it in a 7-inch F9 many years ago, Bay Area.
That sounds like astrophysics.
That's it.
really? Really?
Yeah.
I'll be darned.
Yeah,
Okay.
it's like the telescope we put in the observatory on Montgomery Hill at Evergreen. It was like that, except the one we bought was a Tom Back. So it's the
Oh.
Tom Back version of that telescope. And it's up on top of Montgomery Hill and the observatory we designed.
Incidentally, was there no Westmont Friday night? It was cloudy as hell coming back on the train.
Chuck and
Well-
Tim were there.
Yeah, it was cloudy.
Yeah. So you didn't even go, I would imagine you canceled.
No, we went.
Oh, you did?
We went. We had 6 people show up.
Did you see anything?
Okay, can you see
No, we
this?
didn't see anything.
Can you see
That's
anything?
why I didn't go.
It's definitely going to have to be enlarged, Jerry.
I don't know how to do that on
This
this.
is a lunar
Control
occultation.
plus.
Oh,
Yeah, this is coming out of an occultation of Antares and Antares B. Antares B comes out first.
see the little square looking thing? Click on that on the right.
Yeah, click on the square
Right
there.
Oh, yeah. Good eye.
All right.
Okay.
You can also do a control plus. Or
Thanks.
control
There's
minus.
Antares
There's
B.
Antares B.
Yeah.
Oh, wow.
You see how tough it is to pick off, Tim?
Oh, my God.
And
It
there's
was a
Antares.
cloudy night.
Yeah.
Okay, and there's Antares.
And you saw that in a 7-inch?
7-inch F9. Yeah, it was
Wow.
astrophysics.
One more
And
time.
what helps is putting in an O3 filter, actually.
Yeah, I forget what we used. It was a friend of mine who was in the San Jose club, Rick Newshafer, and he had that scope, and he let us bum it to see that.
Wow. That's amazing.
We saw it in San Jose.
I had no idea it was that small against
Oh,
Antares.
it's real hard, Tim. We got lucky.
Yeah. Wow.
And
Jerry,
Antares is claimed to be, by visual observers, it's claimed to be a green star. And if so, it's the only green star in the sky. But
Well, they
Yeah, go
also
ahead.
say that for Alpha Herculis, I think it is.
Yes,
Okay.
yeah.
but it's believed to be by many to be more of a visual contrast effect than an actual green color to the star.
Yeah.
That is really possible. That's really
Yeah.
possible.
I
That's
think
not-
the companion to Izar might be green, if I remember right.
Yeah.
Izar is in Boötis, the herdsman.
Uh-huh. I missed what you said. Antares is the green star?
No, the
So
companion.
it's cool and red.
Antares B,
Oh, the kind, okay.
the little guy.
Ron, we used to have a test in dentistry where you could put a circle, like a white circle, and then one that was red. And then you stare at the red circle for a long time, and then you switch over to the white circle and it looks green. It's the actual complement of the color.
Yeah,
And that's why they're saying it could be a visual effect.
Called after image.
but I have a question about orbiting. Common center of gravity. When one thing doesn't just orbit the other thing, they orbit a common center, right?
Yeah.
Everything of two is like that.
Okay, if you have a giant like Antares
It's huge.
and a small one which has got what, more mass, which one does the smaller circle?
They're in proportion to their mass.
Right.
Yeah, and the smaller one doesn't have more mass than Antares, Ron.
Oh, it doesn't.
No.
It's way less.
Have you heard of something called the three-body problem?
Yes.
Yes.
Is
It's
that worth
famous.
talking about sometime?
In
I heard it on
freshman
one of-
mechanics
I
in
heard-
physics,
I heard it on one
everybody
of,
hears that the three-body problem has no closed form solution,
That's right.
and nobody believes it. And I spent many lunch hours in the cafeteria trying to prove that people just didn't know what they were doing because I could do it. Turns out you can't.
It's
You have
it's
to
It
do
may
it
look stable in the
numerically.
short term, but in the long term, one crashes into the other.
Yeah,
Or escapes.
All right, yeah, right, or goes off in a wiggle.
but whether it's a stable or unstable system, you can't work out the mathematicals into a single formula. You do what Bruce did in doing it numerically.
okay, but are we talking about three bodies, a
The
trinary?
three body problem, that's what you brought up.
Okay, isn't Alpha Centauri one of those?
Alpha Centauri has a secondary one, the pup. I don't think there's a third star in that system.
Well, Alpha Centauri is Proxima and the two.
Oh, Centauri, excuse me. I was thinking of Sirius.
Yeah.
Forget it.
So there are three stars.
That's a three body system. Yes.
Yeah.
But that
Okay.
it's not that all of those are unstable. It's just that you can't prove that for sure that it's stable or unstable. That is more or less a single body being orbited by a second body, because the two big massive components are very close to each other and Proxima is far out. So that's at least stable over a very long period, even if it's ultimately unstable.
But
Okay.
the orbits of the two stars in the middle very slowly rotate around.
Hmm.
The
Yeah, they
orbit is
process. Yeah.
stay put.
But Proxima A and B only orbit one of the three stars. They don't orbit the whole system.
Proxima A and B orbit each other. They're right at the center. And then I'm sorry. There is no Proxima A and B.
I'm talking about the planets.
Oh, okay. The planets are orbiting Proxima.
Okay, so they're not orbiting the whole three-star system. They're only
No.
orbiting one of the three.
That's correct.
And we don't know if the other two stars have planets around them.
Right.
Wow. You think they could aim the old...
But if those two stars, the other two stars, if they're close enough, that's a tough system for planets to survive in.
Yeah.
So anyway, there is a star that is going to become nova, not supernova. It's a recurrent nova.
Mhm.
We mentioned this once before.
Yeah.
It's on our list of bright stars because it might suddenly get brighter.
Huh.
It's a recurrent nova. This is where it is. It's this red circle in Corona. This is the crown here, Corona Borealis, the northern crown. This is the light curve from 2008 to 2010, showing that it is a variable star. It's not very much variable. This is from a dim 10.6 to a magnitude of around 9.8 at this point. So it does have a trend line down. And when its behavior before, this is from when last time it became a nova, it went down and then it came up. This is the pre-eruption dip. We've had that one with this star now. So we're somewhere in here, and then it suddenly goes up from 10th magnitude to 3rd magnitude, which is about a 7 magnitude. So this is a fusion explosion, a hydrogen bomb on the surface of the white dwarf. And it's because it's got a large companion that's close enough that it's dumping hydrogen onto the small star. And when the weight of that hydrogen gets big enough, then the weight will crush it down, heat it up, and that will ignite fusion on the surface, which will quickly burn up all the hydrogen. And then it will go back into its slowly accreting from the other disk again. So it recurs.
Huh.
Well, if it's fusion, it's becoming helium.
Yep.
Yeah.
Yep. Yep. Yeah, and that change in magnitude represents about 2.5 to the 7th power. It's huge.
In energy output, yeah.
It's a matter of 630
Brightness.
to 1.
And this happens on a regular scale, a regular...
It happens on a roughly regular scale, yeah. Not like clockwork, but on a calendar
Orders of
scale.
magnitude is a linear of 631 to 1. So it's 631 times brighter than it was before it did this.
Huh. Well, it's difficult to see this graph and know what the scale of
It's
time is.
2.5 to the 7th power.
That's right.
Right.
That's what it is exactly.
631 and a bunch of numbers.
Ron, down below, those are years, 1944, 1945, 1946.
I know, but it's going off to the right. When does it do that spike again?
Coming
Well,
up.
that's what we're waiting for.
Oh, so it's about every.
We're in this curve is repeating itself now.
Okay.
We're
Every 80
It's roughly 80 years,
80 years. Okay, well, that's what I was wondering about.
70 something.
Have they not observed the pre-eruption dip already?
Yes.
Yeah, they did.
Now?
Yes, that's how we know we're in this part of the curve.
Yeah.
About to go here.
Oh,
Do you know how far away that star is, Jerry?
Let's see.
1946 was a good year, guys. That's when I was born.
Mm.
I was
Well,
5 years
the
old.
two stars involved are separated by 0.54 AUs. It's got a period or orbital period of 228 days.
Okay.
And I thought I put down here, but I guess recurrent. No.
Yeah. What all I meant, Jerry, is it's probably already happened. We're just
Oh,
waiting.
yes.
We're
Yeah.
just waiting for the light to get here.
Mhm.
So
As always.
So it's projected to happen in the next few months. So before the
Okay.
end of the year. Now,
have they detected shells of hydrogen every 80 light years apart going out?
I don't think they've got actual images of the planetary light feature.
Mhm.
Okay.
So I looked over the internet. I didn't find anything like that. But this brings up an interesting point about seeing things in the past.
Yeah.
In mathematics, you deal with that in E&M fields with what's called a retarded potential in
Mhm.
Green's functions analysis.
Yeah.
But enough of that. This means that when you look out into this night sky and you see the stars,
Mhm.
you need to keep in mind that the stars have never been in that position. They are not now in that position, and they never will be in that position. It's only from this perspective that we see the sky the way we see it.
Right. Yeah. And the star Arcturus, that when you see it, if you do see it tonight in the sky, that light started about 40 years ago, roughly, somewhere in there.
But
I just looked up the distance to T Corona Borealis,
Okay.
and it's 2,700 light years approximately.
Okay. It's out there. Okay.
I'm
it
sure
looks
they
like
have-
So it's already happened several times. There are
Yeah.
several pulses on the way here.
Good point.
That's right.
Yeah, it looked like there was 8 months from that dip to when it went off. It's about 8 months.
Yeah, that looks right, Tim. Yeah.
Okay, now this picture of a crumbly rock, see all the crumbles off of it, is going to spend the rest of its life in a glass container in a museum or under a microscope.
I
Or
think I
some-
tripped over that in the patio this morning.
Yeah, right.
or it'll be in-
You can sell it for a lot of money.
or it will be in-
In my
it'll be in-
barbecue pit.
or
This
it'll be
felt-
in-
Too bad we don't have a coin or a little ruler in here so you can get an idea of how big it is.
That
Yeah.
would be a good idea. Contaminated, but yeah. So this is fell in Gloucester in the UK on February 28th, 2021. It has been analyzed it's considered to be very pristine for a meteorite, even though it's smashed into the roadway or whatever it did. It's been subjected to precision measurements that usually are only applied to sample returns from comets and asteroids. And it has been found, it has revealed that it has a history of being heavily altered by water, by flowing liquid water, as well as smashed apart, reformed, and smashed apart again multiple times. So it's got hydrated minerals next to water-free minerals. It's called the Winscombe meteorite.
If a meteorite lands on your property, does it belong to you?
I believe so.
US. In the US, yes.
Yeah,
In other countries, it's different.
yeah. In
That's-
UK, I think that they're more heavily toward turning it into science things.
Yeah.
If you discover a hoard of old Roman gold coins, you get paid a small portion of what they're worth, and the rest goes to a museum.
But this is all of it, or did it fragment out?
No,
and
No, this is only a piece of it.
only a piece of it?
It's a carbonaceous chondrite, so it's like charcoal briquette.
Yeah.
Didn't work in the del Cielo, right, Chuck? That the ownership of the of the meteor.
Well,
I
see,
mean, right?
Argentina now claims that they, that the country owns all the pieces, so they're not letting pieces out anymore.
Oh, you have to give it back, huh?
Wise move. This was, if you watch British murder mysteries like I do, whodunits, they always rely on CCTVs, closed circuit televisions. England has probably more cameras in across the country than they do people. And one of the set of cameras is called the UK Fireball Alliance Network.
Huh.
And this was visually appeared on that network. So they triangulated exactly where it was, not exactly approximate area. And then they went and found it. So it was a very short time from when it fell to when they got it.
Huh.
Treated very
driveway, was it not?
gingerly. Mhm.
Yeah, this one I think was in the driveway.
Yeah.
In a similar vein with the Chelyabinsk impactor, the big one in Russia,
Yeah.
they
Yeah.
calculated a back orbit really quickly on that because a couple of professors at a university in the country of Colombia had a buddy who happened to be studying in Russia near Chelyabinsk, and they got him to go out and measure the light poles and telephone poles and things like that in Chelyabinsk. And they had so many videos from Russian automobiles because insurance fraud is so rampant that they could then analyze the videos, and from the length of the shadows and knowing the length of the poles, they were able to calculate the angles over which the meteorite moved, or the meteor moved, and calculate a back orbit within like 2 days of when the thing hit.
Good grief.
Yeah.
Good grief, Charlie Brown.
So
Yeah.
this is this meteorite sample that's shown is 602 grams or 21.2 ounces. They did identify that it has been contaminated with table salt, sodium chloride. Apparently it landed near a restaurant.
It's not very big. It's only over a pound.
So they analyzed it with sophisticated transmission electron microscopy, electron backscatter diffraction, time of flight secondary ion mass spectrometry, and atomic probe tomography. So it spent a lot of time inside evacuated instruments.
And they used up most of the alphabet on that.
That is it older than dirt? That's what I want to know.
It is dirt.
It is dirt.
Mhm.
It's older dirt.
Okay. Fascinating stuff.
Okay. We'll see more of that later. For
Ah,
those of you that watched the eclipse last April 8, throughout here in Santa Barbara, we had a partial eclipse, about 50%. And we looked at it with hydrogen alpha scopes, and we saw this characteristic prominence up on about 11:30 or 5:30, depending on which way your scope flipped it. And so this one was probably taken because of the lumps along the moon. This was taken by the moon blocking the sun during the eclipse. So this, in my view, is the spotting feature for pictures of the moon of that eclipse. It's very characteristic. If it doesn't have this feature in it, if it has a different pattern of stuff, then it wasn't this eclipse they're showing, but claiming. There have been so many faked photos of that eclipse. It's just astounding.
Already?
Yes.
We
What-
live in the age of fakery. Truth,
Yes.
doesn't matter.
but my understanding, this is not taken with the partial eclipse we saw. This would be the full eclipse in the middle of the country.
That's correct. This was
Okay.
taken from the full eclipse.
We can
See these little bumps here? Those are mountains on the moon, the profile.
Mountains on the moon.
Our hydrogen alpha telescopes have this as a smooth line.
And one thing about the eclipse, you saw people saying, "Oh, it was between 40 and 45%," and "Oh, it was 50% or 55%," and that's because there are two different measurements that are used for eclipses, and one is called the magnitude of the eclipse, and one is the proportion of the sun's face that got covered.
Right.
And the magnitude one is a weird one. It's the percent of the diameter of the sun that was covered. And that's what was 55%. But when you looked at it, it was, as far as the area that was covered, it was only a little less than 45%.
Huh.
That's why I hedged and said about 50%.
Yeah.
You know, Jerry, with my white light filter, I am able, with some of the eclipses, I've seen a lot of jagged edge on that, show the crater heights and mountains on the moon. And I'm wondering your comment that you see a straight line with the hydrogen alpha. I wonder why they don't.
You see a straight line of the edge of the sun with hydrogen alpha. If you looked at the transition between the moon, the dark moon and the bright sun, you'd see moon
okay.
mountains there.
Okay. Huh. Okay. Got you.
Can I ask a history question, basically? Wasn't Einstein's assertion about gravitational lensing proven by an eclipse?
Yes.
Yes.
I think it was the 1917 eclipse.
We saw
somewhere back there.
We saw some stars or something on the edge of what we wouldn't have been able to see with a
the stars around the sun. There were a few. They were closer to the sun than you would see if the sun wasn't there.
Right.
And it was only by a few fractions of a second of an arc.
Yeah, it might have been 1919, Jerry.
19. Okay, good.
I think so.
But why can't we see that on a regular basis every eclipse?
Because you can't see stars readily around here.
But he did say every eclipse. So yeah, you could. And there was actually for the 2017 eclipse, there was an amateur initiative, citizen science initiative, because it was in a nice star field. To see if you could photograph the stars and measure that deflection.
Wow.
Now, in the 2017 eclipse, Regulus was relatively close to the sun, about 2 or 3 diameters away. Not enough to show the Einstein shift, but you did see the star during the eclipse.
Yeah. Jerry, did anybody see the comet? Anybody image the comet this last
few
eclipse?
days?
Yeah, the last eclipse.
During the
I've seen
eclipse.
nothing. I've researched that, and I have not seen anything
Nothing. Okay.
during the eclipse.
Yeah, I know people were trying to look for it, but I think the sky was just too bright in most places because of the cloud cover.
The comet was about magnitude 5.
Yeah.
And that's just too faint to be seen.
Yeah, we saw it here several nights, before that date.
Okay.
And all the press is saying, "Oh, now's the best time to look at it because it's closest to the sun." And it's like, yeah, but it's right on the horizon.
What I saw is now's your last chance to see it in the northern hemisphere.
Yeah.
Oh, NASA's going to send one of your Teslas to Saturn's moon Titan. Wow.
Well, you notice this is a conceptual design for NASA. Now, Saturn's moon Titan has a very thick atmosphere, so it's not a challenge of a thin atmosphere like in on Mars, the Intrepid or
Ingenuity.
Thank you. This one has got double rotors. It's got 4 of these shafts. They're smaller, and of course this is much heavier instrument. But this is the new thinking about rovers. If the planet you're going to has any kind of atmosphere from Mars to Titan, drones are a better option. And they're having a problem. They've canceled the return mission for the samples that are being laid on Mars to bring them back by another rover that went up there, because it's just simply too expensive. And so they're designing a heavier craft like this to go around to each spot and pick them up and then return them to a lander that does not rove. It just sits there, but it has a return rocket on it that will go up to orbit Mars.
Yeah.
And then Starship will pick it up and return it to Earth.
Yeah. Tim?
That's the current thinking.
Yeah, Tim, do you know it'd be a good nickname for that rover?
No.
Red Rover.
Red Rover. Yeah.
Turn it in. They want suggestions.
Yeah.
And this Titan, Titan one, if you look there, that cylindrical rear end that it has on there.
Yeah.
That looks like an RTG, a radioisotope generator. So it's going to be nuclear powered.
I think I agree. Yes.
And that's usually that has pretty heavy shielding. So, this is pretty impressive that they can raise this thing in that atmosphere.
Well, what they do is they've got all the instruments on this end.
Yeah.
And that back there. So
You
Wow.
know, the guy that was the balloon expert, I can never remember his name.
Julian Knott.
Not.
Yeah, Julian Knott was kind of he was looked at by NASA to create a balloon for the surface of Titan.
They're still working on balloons
Oh, are they? Okay.
for Venus and Titan.
Yeah.
Yeah, he was.
And the NASA scientist that was working with Julian called me up one day and he said, "Hey, are you guys going to be looking at Saturn on your museum, monthly public star party?" And I said, "Yeah." And he says, "Oh, I've got the guy that I'm working with at NASA. He's never seen Titan."
Wow.
You know that they visited me in the cubbyhole, Chuck.
Yeah.
Yeah, I couldn't believe it, and I didn't know it was them until you told me.
Well, we've got a lander and a large parachute lying on Titan right now, believe it or not, next to some rocks that are made of ice, I guess.
Yes.
Going to be
Methane.
interesting. I know what the lakes and rivers are made of. That's methane on Titan. What's the
And ethane.
What?
And ethane.
But what's the atmosphere?
The atmosphere is mostly good old LA smog.
Nitrogen and methane.
Yeah.
There's no oxygen in it at all?
Not much.
Not free oxygen.
Is it already time?
It's time to go, gentlemen.
Time flies when you're having fun. Or was it time flies when you're having flies? I don't know.
I heard there was a rescheduled launch from our Vandenberg on Wednesday, just in time for our speaker to talk about global pollution,
Base jump.
all these incredible things around the earth. That'll be on the night of May 3rd, Friday, and our guest speaker is an expert on it, Dr. Larry Martinez. So want to see you gentlemen with your lovely wives, and take care of yourselves. We'll get back together on this very screen next week, okay? For the SBAU.
Okay.
Happy birthday, man.